Learned about cellular manufacturing group technology and the process of conversion of process layout to cellular layout so accommodate cellular manufacturing. In this unit we are going to deal with flexible manufacturing systems, which is again a system that will suit mid-volume mid-variety production. So in this unit we will be covering types of flexibility, FMS components, FMS applications and benefits, FMS planning and control, and quantitative analysis in FMS. So conventional manufacturing consisted of two varieties of production. One is the job shop type, where the systems were capable of large variety of product but at a high cost. And there was another which was transfer lines, which could produce large volumes of the product at a reasonable cost, but they were limited to accommodate product variety. So, which means they were limited to the production of one, two, or very few different parts. But what is a flexible manufacturing system? Flexible manufacturing system is a system that consists of numerous programmable machine tools connected by an automated material handling system. To be clear, a FMS or FAS is one of the manufacturing machine or multiple machines that are integrated by an automated material handling system whose operation is managed by a computerized control system. An FMS can be reconfigured by computer control to manufacture various products, which means a FMS system can both accommodate product volume and product variety. So SIM is the integration of the total manufacturing enterprise through the use of integrated systems and data communications coupled with new managerial philosophies that improve organizational and personal efficiency. Now you can understand the importance of FMS in the implementation of SIM. When SIM talks about the integration of the total manufacturing enterprise, FMS becomes the very element of it. What is a manufacturing cell? A manufacturing cell usually consists of 2 or 3 workstations, let us say typically CNC machining or turning centers, plus a part handling system. The following 2 slides will contain a CAD layout of a manufacturing work cell. So where you can see that there is a dedicated computer system to control the manufacturing. Manufacturing cells versus FMS. An FMS or FAS, by FAS I mean flexible automated systems, is a manufacturing cell, but any cell is not necessarily FMS or FAS. A FMS is not a complete system that runs automatically. A manufacturing cell has some or most of the components of FMS, but not all of them. If we discuss the history of FMS, in 1950s NC machines first appear, and in 1960s computers appear in the history. Later in the 1960s, flexible manufacturing systems first appeared in the USA at companies like Caterpillar, John Deere, and General Electric Corporation. So the following graph shows the relationship between product volume and variety. Here you can see that transfer lines are most suitable, job shops are more suitable when product variety is high, and transfer lines are suitable when product volume is high. Dedicated systems are suitable again when the volume is high. Automated cells are suitable when product volume is good. So flexible systems play an important role when there is mid variety and mid volume of production. So when the product variety is high, we can go for standalone NC machines, whereas when the product volume is high, we can go for transfer lines, and for mid volume and mid variety, we can go for FMS. So the flexibility or the capability of FMS include machine flexibility, production flexibility, mix flexibility, product flexibility, machine flexibility, production flexibility, mix flexibility, product flexibility, routing flexibility, volume flexibility, and expansion flexibility. Components of FMS include workstations or manufacturing cells, which we discussed already, and a material handling and storage system, a computer control system, and people to manage and operate the entire system. Types of workstations may be loading or unloading stations, machining stations, processing stations, or assembly stations, other stations and equipments like inspection and quality. The layout configuration for a material handling system can be an inline layout, which is nothing but a line layout where inline transfer of goods can happen. It is simply a conveyor. A rail guided vehicle may be used. It may be a loop layout where again a conveyor system can be used. In-flow tow line carts may be used. In a ladder layout, again we can go for a conveyor system. We can go for AGVs, which we will discuss elaborately in the later section. Rail guided vehicles can be used. For an open field layout, again AGVs can be used. Tow line carts may be used. For a large manufacturing industry, a robot centered layout may also be possible. Computer control systems, the workstation, distribution of control instructions to the workstations, production control, traffic control, shuttle control, and workpiece monitoring. All these have to be controlled by a computer integrated system. Tool control, tool locations, tool life monitoring, performance monitoring, diagnostics, all these have to be controlled and operated by a computer integrated system. Why should a FMS be implemented? What will it lead to? It will lead to increased machine utilization. It will require only fewer machines, reduction in factory floor space, great responsiveness to change because it can accommodate product variety, and there is flexibility both in the machines, product, and in the workstation. There is reduced inventory, lower manufacturing lead times, reduced direct labor requirements, and higher labor productivity, opportunity for unattended production because the entire system is going to be automated. Advantages and disadvantages of FMS implementation. Advantages include the process is faster, lower cost, less direct labor cost due to the reduction in the number of workers, reduced inventory, consistent, better quality, savings from indirect labor, from reduced errors, rework, repairs, and rejects. The disadvantages may be limited ability to adapt to changes in product mix, substantial pre-planning activity that is required, that is maybe the tool setup, expensive, costing millions of dollars. It may not be possible in a very small scale industry. Technological problems of exact component positioning, sophisticated manufacturing systems. So, what are the issues or challenges that are faced during FMS implementation? First, the part family considerations, where you have to identify the product and group them into part families based on design or manufacturing. Processing requirements, physical characteristics of the work parts, the production volume, scheduling and dispatching, machine loading, part routing, part grouping, tool management, pallet and fixture allocation requires management commitment and planning, major investment of time and money. If all these can be done, all these pre-planning activities may be done, then the implementation of FMS is no longer a challenge. The other part in Unit 4 of SIM is the Automated Guided Vehicle Systems or the AGVs, which are used for material handling in an FMS system. So, Automated Guided Vehicle Systems or the AGVs is a material handling system that uses independently operated, self-propelled vehicles guided along defined pathways. The vehicles are powered by onboard batteries that allow many hours of operation, mostly 18 to 16 hours between recharging. A distinguishing feature of an AGV when compared to a rail guided vehicle system and most conveyor systems is that the pathways are unobtrusive. Application of AGVs are appropriate when different materials are removed from various load points to various unload points. AGVs are suitable for automating material handling in batch production and mixed model production. The first AGV was developed in 1954 by A.M. Barrett, who used an overhead wire to guide a modified towing truck pulling a trailer in grocery warehouse. Commercial AGVs were subsequently introduced by Barrett. Around 1973, Volvo, the Swedish car maker, developed AGVs to serve as assembly platforms for moving car bodies through its final assembly plants. So the types of AGVs include driverless trains, pallet trucks, and unit load carriers. Driverless trains. A driverless train consists of a towing vehicle, which is the AGV that pulls one or more trailers to form a train. It was the first type of AGV to be introduced and is still widely used today. A common application is moving heavy payloads over large distances in warehouses or factories with or without intermediate pickup and drop-off points along the route. So trains consisting of 5 to 10 trailers is an efficient transport system. You can see that there are 5 or 6 carts that carry heavy payloads. To carry heavy payloads. Automated guided pellet trucks. Automated guided pellet trucks are used to move palletized loads along predetermined routes. In a typical application, the vehicle is backed into the loaded pallet by a human worker who steers the truck and uses its forks to elevate the load slightly. Then the worker drives the pallet truck to the guide path, programs its destination, and the vehicle proceeds automatically to the destination for unloading. The capacity of an AGV pallet truck ranges up to several thousand kilograms, and some trucks are capable of handling 2 pallets rather than 1. A more recent introduction related to the pallet truck is a forklift AGV. This vehicle can achieve significant vertical movement of its forks to reach loads on racks and shelves. You can see this is an automated guided pellet truck where the pallet is lifted by the fork and by the human operator. There are drive wheels and a bumper to move the pallets along the route. AGV unit load carriers. Unit load carriers are used to move unit loads, that is one load from one station to another. They are often equipped for automated loading and unloading of pallets or tote pans by means of powered rollers, moving belts, mechanized lift platforms, or other devices built into the vehicle deck. So this is an automated system. Variations of unit load carriers include light loaded AGVs and assembly line AGVs. The light load AGV is a relatively small vehicle with corresponding light load capacity of 250 kg or less. It does not require the same large aisle width as a conventional AGV. Application. Light load guided vehicles are designed to move small loads through plants of limited size engaged in light manufacturing. An assembly line AGV is designed to carry a partially completed subassembly through a sequence of assembly workstations to build the product. Applications of AGVs. Automated guided vehicles are used in a growing number and variety of applications. An application area is the storage and distribution. Unit load carriers and pallet trucks are typically used in these applications, which involve movement of material in unit loads. The applications often interface the AGVs with some automated handling or storage systems, such as an automated storage retrieval system in a distribution center. The AGVs deliver incoming unit loads contained on pallets from the receiving dock to the assembly station or the receiving station, which places the items into the storage, and the assembly station or the receiving station retrieves individual pallet loads from storage and transfers them to vehicles for delivery to the shipping dock. Storage distribution operations also include light manufacturing and assembly plants in which work in progress is stored in a central storage area and distributed to individual workstations for processing. Electronics assembly is an example of these kind of applications. Components are kitted at the storage area and delivered in tote pans or trays by the guided vehicles to the assembly workstations in the plant. Light load AGVs are the appropriate vehicles to be used in these applications. AGV systems are used in assembly line applications based on a trend that began in Edo. Unit load carriers and light load guided vehicles were used in these lines. In the usual application, the production rate is relatively low, the product spinning perhaps 4 to 10 minutes per station. And there are different product models made on the line, each requiring a different process time. Workstations are generally arranged in parallel to allow the line to deal with differences in assembly cycle time for different products. Between stations, components are kitted and placed on the vehicle for the assembly operations to be performed at the next station. The assembly tasks are usually performed with a work unit on board the vehicle, thus avoiding the extra time that will be required for unloading or loading of the component carried. Another application area for AGVs is the flexible manufacturing systems, which we learned in the earlier part of the unit. In typical operation, starting work parts are placed into pallet fixtures by human workers in the staging area, and the AGVs deliver the parts to the individual workstations in the system. When the AGV arrives at the assigned station, the pallet is transferred from the vehicle platform to the station, such as work table of the machine tool, for processing. After the completion of processing, a vehicle returns to pick up the work and transport it to the next assigned station. An AGV provides a versatile material handling system to complement the flexibility of FMS. Applications in hospitals and office malls. Hospital guided vehicle transport need trays, medical, linen, and laboratory supplies and other materials between various departments in the building. The transport typically required movement of vehicles between different floors in the hospital. Hospital AGV systems have the capability to summon and use elevators for this purpose. AGV interface with robot. AGVs can also be interfaced with a robot, and the technology is still developing, and the industry is continually working to design new systems to respond to new application requirements. An interesting example that combines two technologies involves the use of robotic manipulator mounted on an automated guided vehicle to provide a mobile robot for performing complex handling tasks at various locations in the plant. These robot vehicles have potential applications in cleaning rooms and in the semiconductor industry. Vehicle guidance technology. Three technologies that are used in the commercial system for vehicle guidance are the embedded guide wires, paint strips, and self-guided vehicles. Embedded guide wires and paint strips. Electrical wires are placed in a small channel cut into the surface of the floor, that is, the shop floor. The channel is typically 3 to 12 mm wide and 11 to 26 mm deep. The guide wire is connected to a frequency generator which emits a low voltage, low current signal with a frequency range of 1 to 15 kHz. You can see that when the AGV moves, there is a sensor coil that induces a magnetic field along the pathway that can be followed by sensors on board each vehicle. The AGVs have a sensor which can detect this frequency and follow the path. When paint strips are used to define the pathway, the vehicle uses an optical sensor system that will track the paint. So the vehicle will move along the paint track. The strips may be taped, sprayed, or painted on the floor. Paint strip guidance is useful in environments where electrical noise renders the guide wire system unreliable, and when the installation of guide wires in the floor surface is not mostly possible. So this kind of paint strip system is used in most of the AGVs. Self-guided vehicles, they operate without defined pathways. They use a combination of dead reckoning and beacons located throughout. Dead reckoning refers to the capability of a vehicle to follow a given route in the absence of a defined pathway on the floor. Movement of the vehicle along the route is accomplished by computing the required number of wheel rotations in a sequence of specified steering angles. The computations are performed by the vehicle and the computer on board it. Positioning accuracy of dead reckoning decreases with increasing distance. The location of self-guided vehicle is periodically verified by comparing the calculated position with one or more known positions. These known positions are established using beacons located strategically throughout the plant. Vehicle management, traffic control in AGVs, onboard vehicle sensing, zonal control. So when there are many AGVs that are employed, these vehicle management systems is very required. So the guide path is there. There are many AGVs. So They are controlled, they are divided into different zones, and they are controlled. Vehicle dispatching, remote call station. So, what is the safety feature in a AGV? That is, traveling speed is slower than normal walking pace of a human, which means it is less risky. Automatic stopping of the vehicle if it strays more than a short distance, typically 50 to 150 mm. Vehicles are programmed either to stop when an obstacle is sensed or to slow down. When the safety bumper makes contact with the object, the vehicle is programmed to brake immediately. So I hope you understood about AGVs that are employed in FMS systems. That's the end of Unit 4. I hope you understood. Thank you.